Are we going to go over the answers together?
Yeah, so let's see. So this is saying with the normal probability applet. So you said you figured it out, Jessica, so we'll just have to plug in those numbers of...
Yeah, all you have to do, from what I understand, is just plug in the Z's and then highlight the middle, only the middle part.
Then what?
Then highlight only the middle part.
Combined area under the standard norm occurs that is to the right of Z and to the left of Z. Okay, yeah, that makes sense.
Wait, hold up.
Minus.
Oh, oops. You don't highlight the middle, you highlight the outsides.
1.3. What was that? 1.3 what? Negative
1.358.
358. Okay, so if we are trying to get, but it's supposed to be the part under the curve, is that what we're supposed to find?
So,
and then get rid of the side, the area under the curve?
That's to the right of Z and to the left of Z. So it's the
okay.
not the middle.
Okay, so it is those things. Okay.
Yeah, so it's not the center. I got 0.175.
Okay, yeah, 1745.
Yep, that's what I got.
Be 17. So it'll be 0.175. That's the rounding rule, right? That if it's 5 or above, you round it up?
Correct.
Okay. I thought I remembered that right, but it's been a long time. All right, so that's the answer. 0.175.
So, do we want to go ahead and move on to the next one?
Yeah. Or I think everybody's got that right.
So it says, which of the following will have a smaller if 9 observations are randomly drawn from a population of individuals' observation, the distribution of the sample means, this cannot be determined from the information given.
If 9 observations are randomly drawn from a population, which will have a smaller standard deviation. Okay, well, I don't understand that question. I don't know how to figure that out. What do you guys think? If 9 observations, so it's a small sample, are randomly drawn from a population, and this isn't a sample. Distribution of the individual.
From what I understand about these, when you draw the populations, no matter what the number is, the more populations you draw, the smaller the standard deviation is going to be. So whether it's 9 or 30 or 45, the more you draw, the smaller the deviation is going to be. So the smaller standard deviation should be the distribution of the individual observations. That's what I got.
Okay, well that makes sense. Distribution of the individuals. All right, so I got to make a note of that because that's an important thing. So when you draw from the population, but it's the larger the sample, the smaller the deviation, right?
Correct. Because you're taking more specific information.
Smaller standard deviation. Distribution.
So it's the first one?
Well, now let's see.
Yeah, I have a question about that because
of the sample mean. The distribution of the sample means has a smaller spread, though. Is there a reason why it wouldn't be that one? Because isn't that
That's the one I
law
got, the
of-
sample mean.
Yeah, because that's the large number thing. So the distribution of the sample mean. Okay. Well, so what do you think, Joseph? Do you think that's right?
Which one?
Well, we're kind of thinking it's the distribution of the sample means because of the law of large numbers, which says that that is going to have a smaller standard deviation than just a regular sample.
I don't know. Sounds good to me.
Well, I mean, it seems like that's what that says, that when you have more, okay, well, that's what I think it is. I'm going to put that. Okay, all right, so number 5. Which of the following results implies that the spread of what's that called? What does that mean? Oh, so that's what they're asking. So
Yeah.
that's the law of
You just did it.
that's the law of large numbers, right? Because that's the one that talks about the spread. Well, so are they going to have 2 questions in a row that I don't know. But that, I don't know. To me, that seems like that just says that last quote. We got the last one right. Okay. Use the following information to answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8. All right, so then this one, don't we just go back to that regular, that formula that we used before, the simpler one, that is
Z equals
now let's see.
minus mean divided by standard deviation.
Oh, what is the
Yeah.
z-score corresponding to Diane? Okay, so then that, okay.
So the value minus the mean divided by the standard deviation.
Right.
So the
Yeah.
value is 160 minus 150.8. Divide that by
It would be
8.8.
150.8 minus 160.
What? It says the value minus the mean.
It's 150.8. Okay, I guess I'm saying the same thing.
Okay, so 9.2 divided by 8.8.
Yeah.
Is 1.045.
Yeah, so that would be 1.045. Yeah, because we don't round it up.
Okay.
Okay, so this is.
I have a question really quick. What was
Yeah.
number 5? I didn't hear that. Sorry, my roommates were talking.
The law of large numbers.
Okay, thank you. Okay. So what is the probability that randomly selected students will score above 160 on the quantitative? So that,
Yeah.
So we have to go to the applet.
yep, and put in the thing that we just did. So 1.045. That would be 1.148.
Okay, and then, so now I've got to think, so what's it asking for? What is the probability that it'll be what?
Above the mean. 160 is the mean.
All right, so,
Oh, no. Never mind.
It's above the z-score. So the 1.045, it's above that.
so it's the, oh, so how do you know that?
Point
So
one
it-
four eight.
So we
That's
put
what I
that,
got.
you put that in the middle section?
No. You
No.
put it on the right.
Oh, yeah, because it's above.
It's above, yeah.
Okay. But did it say something about the 40th percentile, or am I mixing that up?
40th
think-
percentile.
You might be mixing that up.
About that. What is it? So what is it looking for? I can go back to that.
Just what the probability is that somebody will get above 160.
Oh, above 160. Okay.
Yeah.
Got it. Okay. Yeah, I don't know where I got the 40th percentile.
Science, Mom?
Okay.
Your class?
So random doesn't get into sciences than you do.
0.
My teacher says, avoid to do something.
Okay. So then on question 8, a random sample of 5 students was selected to take the GRE. Their scores are
Oh, 5 done.
So
It's the same thing as the other.
So we just add those together and then divide them to get a mean, or not?
You add them together and divide them by however many it is. So you add those together
160.
and then divide it by 5.
How much is it? What's the answer?
The mean was 160, so it should be the same for the
As it was before.
z-score before.
Oh.
0.45.
Well, so that doesn't have anything. So we're not supposed to. Yeah. So we're not supposed. That's just giving us weird information.
It just happens to be
No.
the same.
Yeah, sorry, I cut him off, but he was right. It just happens to be the same as the stuff that they gave us earlier.
So what if? So what if that the sample of 5 students does not equal the mean? Are we supposed to? Well,
You just
we're
do
supposed to
exactly
go
what you
back
did before.
You're supposed to go back and use the mean that was already given to us, right?
No. So you just use the formula that we used the first time to figure out the mean for the first one.
okay. Thank you.
Okay, so I'm not understanding that. Let's see. So, but so if the mean and the sample mean, if the population mean and the sample mean are the same, isn't that right?
Mm-hmm.
So then what does this have to do with these random selected numbers? What are they trying to say by that? Because does that give us any information? Oh, okay. So then number 9, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean? Oh. Okay.
So basically, so what's happening right now is the question 8 is completely separate from the other question.
Okay.
So it just happens that 160 is the mean. But if 160 wasn't the mean, you would use the formula to find the z-score, or the z whatever.
And so the answer is what we already got up above?
Correct.
Yes.
Okay, which is
1.045.
okay.
That's for question 8. And then for question 9, it's 1.148.
What are you doing? No. Hiram, no. Hey, don't do that to her. That's mean. Grabbing like that, that's mean. I think you need to go up to bed. Go color or something. I'll be up in a few minutes. We're not doing origami tonight. We already did origami. It's bedtime.
So why is number 9.148?
What did you get?
I didn't get an answer yet.
So it's asking the same thing as it was asking for number 7. So it's asking what is greater than the mean scoring that was given for number 8, which happened to be 160.
Okay. So it's just a duplicate because, okay.
Yeah.
They just added extra words and it got me confused. All right, I'm good.
What? Well, I'm still confused. All right, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Oh, okay, so that is the same amount because we put it all into the applet and we looked to the right of the z-score, right?
Yes.
So, and what was that number?
0.148.
148. Okay. Well, that's kind of strange that there's so much repetition. Okay. So, suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn.
Number 10 should be approximately normal since it's over 30.
Right.
It should be normal, or
Okay.
approximately.
Okay. Now, no wonder she said that that is really a great law. Because that sure makes things easier, doesn't it?
Mm-hmm.
It's just pretty simple. Okay, so question 11. I haven't saved 6, 7.
What is the mean distribution of the sample means for all possible sample size 81 that could be drawn from the parent population? What is the mean?
Mean should be about 3.5, right?
Yeah, the mean didn't change.
Yeah.
Because it's over 30.
It's 0.7.
So then that just means that, so that's 3.5 then, right?
Mm-hmm.
Mm-hmm.
Okay, because the sample, the mean and the population mean and the sample mean are the same. as long as it's a big enough sample. Okay.
Yeah.
All right. Makes sense. 12. What is the standard deviation of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population?
So that's the formula that is the standard deviation divided by the square root of the population size, like the square root of the sample size, right?
I think so.
All right, so let's see, what is that? That is, oh good, we get to use that. I don't know, I just think it's fun that that actually comes out right. All right, so it's the value.
So it's 0?
Value minus mu divided by the population standard deviation divided by the square root of the population size, which is 81, right? Is that what we put in there? It's the square root of that population size, right?
Yes, I got 0.
But does this give us enough? Okay, the standard deviation is 0.7.
0.078 is what I got.
Yeah, I got 0.078 also.
'Cause it should be 0.7 divided by 9 because 9 is the square root of 81.
Right.
Okay.
So 0.7 divided by 9 is 0.078.
I was using the wrong formula. Sorry.
And then up at the top, let's see, the mean is 3.5. And then the value.
That's the wrong equation for number 12.
Huh?
That's the wrong equation for number 12. For number 12, you just need the standard deviation and the square root of the sample.
Oh. Okay, so you just need the bottom part.
Yeah, so it's just 0.7 divided by the square root of 81, which is 9. So the answer is 0.078.
So I need to write that in a way where it makes sense to me. So the standard deviation of the distribution of sample means, okay, and so then what is that other thing? Oh, that's the z-score. So that other one where you have to add in all those other things?
Yeah.
That's the z-score. Okay. I mean, that's the other. Okay, got it.
Yeah, the z-score uses the sample mean, but the standard deviation does not.
Okay. So then that's just a much simpler equation.
Yeah.
All right. Okay, do we get to do that other one? Maybe? Let's see what the next one is.
This one we put in the applet.
Oh. All right, what is the probability for 81 randomly selected BYU Idaho students will be less than 3.3?
So we have to find the z-score and then put it in the applet, right?
I believe so.
Yeah.
So then that would be 3.3 is the value, right?
3.3 minus 3.5.
Minus the mean 3.5.
Divide that by
Divided by, what was the standard deviation?
0.7.
Oh, that's right. 7.
0.28. And it was asking less than.
Yeah. I got .045.
Right.
Now,
I got
when do
0.387.
we use the when do we use the other formula? This is the other formula because it's this is the value minus mean over the the standard deviation of sample means. Because it's left skewed, we couldn't use the normal probability applet, so we have to do it. Oh dear.
But since it's a large
Um,
population, can't we? Since it's a large population?
no, exactly. So we have to use the other formula. So the formula is value minus mean over, and it's the standard deviation of sample means. So it's not just your standard deviation, it's your refined standard deviation that we found for the last question.
Oh, I see what you mean. Okay.
Okay, now why don't I get that? So say that again, so we don't use that, that formula?
We use the formula that we talked about. We just don't use the standard deviation that's at the beginning of the question. We use the standard deviation for the one we just found out.
Oh.
So instead of using 0.7 for the standard deviation, we're using 0.078.
So for that, I got 0.005.
Yeah, that's what I got too.
Okay, that makes sense.
I hope so. I'm reading the textbook and I'm like, this didn't do it right, but I'm pretty sure that that's what we need to be doing.
The mean will be less than 0.3. Mean. So I don't know if I could think of that on my own. Tell me how I could
I know, I'm trying
be able
to
to
find out how to
realize,
tell you how to do it.
because I think I would get confused. That doesn't seem.
Yeah.
Because there's a step in there that I'm not getting, where it's leaping from one thing to another. That the mean will be less than 3.3. Yeah,
No,
I don't get it.
I think the time that you do this is when it's not normally distributed. It said it was going to be left skewed, plus we have a large size, and that's when we would do it.
But if
I
it's
think if it
left
were normally
skewed,
distributed,
then it's going to be normally
yeah,
distributed. So why are we using the sample mean?
because it's not normally distributed unless we're using the central whatever theorem. But when we're using that theorem, then we have to use the sample deviation, not just our normal deviation, but the standard deviation of the sample means.
Okay, so what did everybody get for 14?
I got 0.99.
I got 0.995.
Okay. Oh, okay. Never mind.
Okay, I'm going to have to go over those.
Yeah, you'll go to the TA meeting in the morning, right?
Yeah, I can do that, or I can just call my son and have him.
Oh, that's true. Maybe they can explain it better than we can. So like, the central theorem or whatever it is, that only happens because our standard deviation changes, because it becomes smaller. And that's why we do that calculation showing what our sample deviation is becoming. But because we're using that new standard deviation, because it's changed because of the theorem, we can't do our calculating with the old standard deviation. We have to use the changed one.
Okay.
I don't know if that makes any sense to you at all.
No, that sort of is making sense. It does make sense. Yeah, yeah. Well, it sort of makes sense. All right, I can go with that and just figure that out. I mean, I'll just keep working with that. I'm sure it'll all of a sudden make sense to me. So, all right. So, are you guys on 15?
Working on it.
Okay.
Yeah.
Okay, so for 15, I got 0.781.
Not 0.782?
Oh, sorry, yeah, 0.782, my bad.
Well, I got.
My Excel is spazzing out, so I haven't gotten that far yet. But I'm guessing if you both got the same one, it's probably it.
By the mouths of 2 or 3 witnesses, right?
Yeah.
All right. So, how did you figure 15 out? What formula did you use? The standard deviation, the weights of a random sample. So do we use the formula that has, did you figure out the z-score for that? And then put it in yeah, because if you've got to find the probability, then you have to put it in the probability applet, right? And you need to get a z-score out of that. Is that correct?
Mm-hmm.
Okay. All right. So you did that.
Okay, we have some fixing to do here.
Oh, yep.
I submitted it and we got 4 wrong.
Did you guys get
Well,
15 wrong?
Yeah, we got 15 wrong.
Okay. Well,
Yeah, I'm just looking and I'm sure we did that one wrong. So which ones did we get wrong?
We got
15, 13,
9.
and 8.
Wait, we didn't get 13 wrong. Or I didn't get 13 wrong. I only got 15.
Oh,
Well,
what did you put for 13?
13 at point .005.
13?
Uh-huh.
Okay.
Let's see what 9 and 8 are.
So have you seen that
So
Subaru?
I'm recalculating 8 and 9.
Were you on conference?
Yeah.
Alright, let me retake this.
Is there a mouse, maybe? I might use it because this is just spazzing out and I can't use Excel and it's making it.
Could it be that we have to do what we did for the other one? The
Okay.
Okay.
could question 8 be 0.696?
So then, just a sec. That's 160. Oops. What did you get?
For question 8, could it be 0.696?
Yeah.
Okay.
So number 8
How
is
did you get that?
0.696.
How did I get that?
I got something completely different. That's why I'm wondering how you got it.
Well, because the first time that we did it, we just did the mean, and then we just used that with the other, if that makes sense. Could it be possible that we had to use a different formula to get it? So instead of using the 160 or the formula we got for this one, we used the other one. So the formula for standard deviation.
Yeah, that's what we need to do.
Yeah, because that does say the sample.
Because it says the sample.
So as the sample mean, we have to
Yeah.
use that other formula, right? Okay.
Yeah, so I did it wrong. My Excel's just freaking out. But what did you get? It's 0.6 what?
9.6.
Point.
Okay.
Okay, so we have, I'm working on 15.
And we need the answer to number 9 as well.
Yeah.
Give me a sec.
Oh, because we started with the wrong,
That would be
The wrong-
0.243.
and that's why that was different, because we started 0.243. Is that what you said? Number 9 is
243.
0.243. And that is different because we didn't start with a z-score based on the sample mean. Is that correct?
Yes.
Okay.
All right. And then, let's see, 15.
So
Could it be possible that we have to do the same thing with this one as well?
let's see.
Yeah, because it's saying the sample mean. Yeah, so we have to do that one with this one as well. Gosh dang.
So what's the difference in the formula?
Well, the sample
You're
mean
just
is
using
the one
the
that's got the standard deviation divided by the square root of the sample on the bottom, on the denominator.
sorry, what answer did you get for number 8?
Uh, 0.696.
And that's the Z score you found? I got a very different Z score.
No, that was the I didn't finish the problem. That's probably what it is. I only did the standard deviation. I didn't finish it. So I have to do well, hold up. So if I do 160 minus 1. What was it? 1.
It works. Nope, it's still freaking out though. Not very many.
Okay, so what do we have for number 8?
No.
I got 2.34 because I did 160 minus 150.8. I got 9.2. And then to find the standard deviation for the sample mean, I found the square root of 5, which was 2.24. So I did 8.8, which is the standard deviation, divided by 2.24, and I got 3.928, whatever. And so then I divided 9.2 divided by that reduced standard deviation.
And so what question is that?
Sorry, Shauna, can you ask again?
Yes, Jenica, what question was that?
This is question 8.
This is 8. Okay, let me
Just a sec, I'm gonna get my headphones and then I can walk you guys through it and you guys can tell me. I'm really tired tonight. But I think I did it right. I did it 3 times. So just let me get my headphones and
Well,
walk
it
through it.
sounds all right.
And that was 2.34.
The z-score corresponding with the sample mean of these student scores. I don't see where she's getting that answer.
Gosh.
Because she divided it by the 5 students instead of the actual GRE score mean.
Well, because we have a sample population of 5, so I found the square root of 5. Like, our n for question 8, it's n equals 5.
Oh. So it's 9.2
Does that make sense?
divided by the square root of 5.
Where'd you get the
No.
9.2?
So 9.2 is 160 divided by 1, or 160 minus 150.8. So that's
Right.
the 9.2. That's the number that's, okay. So then to find the number we're dividing by, we have to find the standard deviation. So that's standard deviation, which is 8.8. Then we divide that by the square root. Oh, for this, we have an n of 5 because we have 5 different.
But isn't the 8.8 meant for the 8? That can't be.
We always use O. So to find the standard deviation of sample means, it's O divided by the square root of n.
Well,
So that's what
no,
we're finding
it's
right
not
now.
that I'm confused about. What I'm confused about is it seems like you're taking the standard deviation, but that's the standard deviation for the GRE scores, not the students.
No, I'm not taking. Oh, I see what you're saying. You wanted to find a new standard deviation for those scores.
Yeah, it's the scores,
Is
not
that
the
what you're
students
saying?
that matter.
But O equals 8.8. We don't need to find a new O. Like, we're still using the same U. We're still using the same mean. So we'd be using sigma, which is 8.8. I don't think we need to find a new standard deviation. We're just filling in the formula. So standard deviation is sigma divided by the square root of n. I don't think, and it gives us sigma at the top. Like, we're using the same mean. I don't know why we'd need a new standard deviation. Like, we're getting the standard deviation of the sample means. I don't think we need a new sigma. They already given that to us.
So what did you get for your answer? For 8?
I got 2.341.
0.341?
2.341.
Pardon me?
2.341?
2.341?
Yeah. I could be wrong, but I just don't see anywhere in the textbook or examples or anything that says that we need to find a new standard deviation.
And
So
I started figuring out 15, but now I've gotten lost.
Yeah. There's another for 15 there is another formula. I need to find it, but I'm still working on 8 and 9. Like I
Okay.
just wanted to make sure I was right on those.
So that was different than the original answer we had, correct?
2.341, yes.
That was different from the original answer we said?
Yeah, our original answer was 1.045.
2.3.
It is different. As far as I can tell, I did the process right. I filled in everything. I'm hoping it's right.
So the next one is 0.00. How would you put that? Oh gosh. 0.01?
0.00. Oh yeah, I think it'd be 0.01.
For which question?
9.
Oh. So that wasn't the
It's 3
.243?
decimal places, so I think it's 009. Oh, no, because you're right. It's 0.01. I think you're right.
So the answer to question 9 is 0.009?
The answer to question 9 is
No,
0.01.
0.0.
Oh, 0.01.
Yeah. Do we have anything for 15?
Well, I
There's
got,
a formula.
like, you don't think it's that same formula, huh?
No, because they want to know, they want to know, find the probability that a random sample of passengers will have a weight that's as extreme or more extreme, either above or below the mean that
So
was observed in the sample.
So don't we need the z-score for that? And then to put it in the probability applet, is that not right?
I know. Well, I'm not sure if it's right or not. I just remember seeing something that was about a spread. Like in between these two numbers or whatever.
Oh,
And
I
I just
yeah, I know
want
what
to
you're
look at
talking
the
about.
formula and see if you know what I'm talking about. I just want
Yeah.
to look at that formula and see if that's what they're asking for or not.
Yeah, that was in the
Like
the
5,
book.
I think, or 4.
Yeah, that was in the book from last week, I think.
Was it? Yeah, lesson 5 or lesson 4, I think. So that's what I'm looking for right now. I don't know if that's what they're asking. I just want to look at it again and see if that's what they're asking. Oh.
As extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also the values that are as far away from the mean as ours in the positive direction.
What are you reading from?
So that's the note underneath there. So that just leads me to believe that we need to put it in the probability, whatever it is in the probability applet, because that would give us those values. Or the,
But what doesn't make sense to me? Like, so then are we finding two z-scores one for 77.6 pounds and one for 185 pounds, and we're finding what's below that range and above that range. Is that what we're finding? Because,
No.
I mean, if we're talking about one specific tiny little z-score and we're finding everything over and under, we're at like almost 100%. So, so it seems to me like we're looking for a range. Tell me if I'm wrong. That's how I'm understanding it.
So what? So you haven't found that other?
Well, I
Oh,
think for
sorry,
sure we put it in the
I'm just-
probability applet, which is going to give us
Yeah.
one definitive number.
Okay, so I don't know what you guys are using, but I got 0.055.
So can you tell me, like, can you go through the steps of that with me? Because I'm having trouble understanding exactly what it's asking.
So you got 0.055?
Yeah.
Pardon
I
me?
don't know if that's right, but that's what I got.
Yeah, do you mind just going through the steps of that with me, just so I can? I'm like trying to get a handle on exactly what they're asking, and
So I think it's similar to the questions above that we've been doing. The only difference would be the fact that they're asking for the extreme. So basically they're asking for the mean that's greater than the mean, or the area or whatever that's greater than the mean and less than the mean, but not in between. So basically, oh gosh, here, I'm going to share my screen so you guys can see it.
Thinking.
Okay, let's see.
Do we know what we put last time?
Yeah, you guys put 0.782.
Okay. Now, if I understand this one correctly, we're going to do 177.6 minus 185 divided by the square root of 48.
Close. You're close. Okay, so this is, I'm sharing my screen at the moment. So if you look really quick, so basically this is what I got right here on the z-scores.
How?
Okay, so what I did was, you were close. Okay, so I used the formula, let's see, hold up. No, that's not what I wanted to do. Okay, so I used the sorry, I gotta find it. Where is it?
Now, when you find the score, right?
Ah, there's. So that divided by the square root. I would have to find that. Basically, here, this is what I put into my calculator. I did the
By 40, square root of 48, right?
and then the square root of 48, yes, which was some ridiculous number like 6.28.
92820,323.
Yeah. So that's the bottom part of it. And then on the top part, you do the 177.6 minus 185.
7.4. And then we do 7.4 divided by that 6,928,20,323.
Uh-huh.
And then we get 3.853813047. Is that right? Is that what you got?
Okay, so you guys gonna go?
Do you want anything?
Sorry, this is taking longer than I expected.
Do you want to go? Because we can wait.
I mean, if you guys want to go, if you're in a hurry, then that's fine.
Hey,
I can get you
Jeff,
something.
if you want to submit your answer and take off, that's okay.
Sorry?
If you want to go, it's okay.
Well, hold up one second.
That answer is correct.
Okay.
Just because the answer's correct?
Yeah, we got them. We got them all 100% correct.
Sorry, what did
Okay,
Jessica
so you
get?
just go and get things done.
15?
So 15 is 0.055. Is that
Correct.
right?
Correct.
And then let's do 8 and 9. Okay, so I think I was on the right track. I just got sidetracked. And then,
So 8
I
and
forgot to do
9.
the standard deviation.
so 9 is 0.01. Is that right?
Yes.
And 0.2341 is right?
Correct.
0.341. Okay.
Do you mind? I kind of missed part. Do you mind if I just go over my answers with you to make sure I have them right?
Yeah.
Yeah,
which
like-
You don't
the
mind?
questions on?
Okay, question 3.175.
Correct.
Question 2, the distribution of sample means.
Correct.
Wait,
The lar-
sorry. Can you do that again? Because I don't have that. I didn't fill it in. So can you start from question 3 and then just go down again? Sorry.
Yeah. Yeah, it's fine. 0.175.
Correct.
Okay.
And then 4 is the distribution of sample means.
Correct.
And then 5 is the law of large numbers.
Correct.
6 is 1.045.
Correct.
Are you following, Jessica?
Yep, I am.
Okay, didn't want to go too fast. Okay, 7 is 0.148.
Correct.
Are we supposed to put the leading 0 there or not? We don't need to?
I don't think you
Just
have to.
0.148?
You need to. I have been, but I don't think you need to.
I think it counts both.
Okay. Okay, then A is 2.341. Is that? Go ahead, Joseph. You say what you have.
Yeah, 2.341.
Correct.
And then 9 is 0.01.
Correct.
10 is approximately normal.
Correct.
11 is 3.5.
Correct.
12 is 0.078.
Correct.
13 is 0.005.
Correct.
14 is 0.995.
Correct.
And 15 is 0.055.
Correct.
Okay.
Okay, awesome. So this makes me a little bit worried for the exam. because it's like, okay, when do we do this and when do we do that? And I just need to make sure that I know when we're doing the right thing.
Yeah. All right. Well, I'm gonna go. Thank you
Have
for the help.
fun.
We did good.
Yeah, I gotta go too.
All right, good night. We'll see you
Right.
again
No, you guys
on.
are good. Have a
So
good
do
night.
we have regular meeting next Tuesday, even though we have our exam on Tuesday and Wednesday? I guess.
I don't know. I didn't look.
Okay.
All right.
Well,
Here, I'll go look right now.
because
You
I
guys
don't
can
know
go.
if
Have a good night.
we're going to be tested on
Well, we could, even if we
lesson
don't.
8 or not.
So even if we do or don't have a group meeting or like an assigned group meeting, we can still get together and just do the study guide together.
Okay.
No, we have a group meeting.
Okay,
Oh.
so we have a group meeting for lesson 8.
Yeah.
Is that on the
It's
exam?
review for and take unit.
Oh,
Pardon.
so
Yeah, it looks like it.
so Tuesday is a review for the unit exam? Oh,
Yeah.
okay, well that would be nice, so we can review.
Yeah.
Okay, well then I'll see you guys then.
Okay,
And there's a
All
right.
chapter.
All right.
Yeah, have a
Bye.
good night. Bye, Joseph. It looks like chapter 8 in the textbook is all just review for the exam.
okay. Okay,
Yeah.
well then that'll be good. Then we can do that and take the exam on